standard deviation problem that my Oxbow students have been working on this week. This is the third week in September in 2016. And maybe I should do this for you to help people that are having a hard time calculating this by hand. There's some good thinking that comes behind this problem too. So even though by the hand, even though you're doing it by hand, I'm not going to encourage you to do it by hand. I mean, use technology, but coming out of doing this by hand will help you. It should help you out. So they're saying decide which. What are they asking me here? I don't know if I've done this part of it. Without doing it, decide which is the larger standard deviation. Explain why. Well, one way to do this is to make a graph, and one thing, one easy graph to make is a dot plot. 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 10. So for this first set of data here, let me get fancy and change ink. So 3, 5. Notice I'm not doing any calculation. I'm just getting a picture of the distribution. And 9. And then if I graph the other one, I get, let's see what, 2, and then 4, and then 6, then 8, then 10. So what I'm seeing is the red set has less variation than the blue set. So this should have a smaller standard deviation because there's less spread. So let's verify that. So what you have to keep in mind is, well, what's the formula for the standard deviation? Well, you're going to find the deviation from the mean. In other words, how far away each of the numbers is from the mean. We're going to square that deviation. We're going to add up all those squared deviations up to find this, to find the sample standard deviation. We're going to divide by 1 less than the number of data points that we have and take the square root. So if you haven't copied down that formula yet, I would. I'm going to get rid of it because I don't have this screen space to do everything and have it on here. So, well, maybe I can shrink it. Let's see. Is it going to let me shrink it? Oh, look at that. Isn't technology wonderful? Oh, let's shrink this up. Well, I won't be able to see the numbers. Here we go. Okay, so here's what I recommend you do when you do this calculation by hand. Make a column, call it X. Put all your data there. So 3, 5, 6, 7, 9. Then the formula says find the mean. All right, so let's see, I'm getting the sum. Let's see, so if I add 12, and 12 is 24, plus 6 is 30. So 30 divided by 5 is 6, so my mean is 6. So then it says find the deviation from the mean for each of the data points. So 3 minus 6 is negative 3. 5 minus 6 is negative 1. This should be 0, shouldn't it? Oh, no, it shouldn't be 0. I messed up. Just a minute here. And I might have totally botched it because I don't know if it'll let me erase it. Nah, it's not going to. So you're going to have to pretend that that's not there, and I've got a 6 here. 6 minus 6 is 0. That's where the 0 is coming from. 7 minus 6 is 1. 9 minus 6 is 3. What I want you to notice here is if I just add up these deviations, I get 0. That'll always happen because the standard deviation is the mean is based. I'm sorry, the mean is based on these numbers. So that's why the statisticians decided they needed to do something more to make this be useful. I mean, sometimes some measures that will take the absolute value. They talk about the mean absolute deviation. I've never seen that used in real life, so I won't go there. But what we decided to do, or the statisticians decided to do, is we're going to square each of those to get rid of the positive and the negative. So I'm going to take that deviation and square it, and then I'm going to square each of these numbers. Now what you got to remember is squaring means to multiply a number by itself, not take the square root. So if you're going to use a calculator, you're going to hit the x squared button, not the square root button. Okay, that's wrong. Don't use that button. We're squaring it. The square root button's for later on. So I'm going to square each of these numbers. So negative 3 times negative 3 is positive 9. Negative 1 times negative 1 is 1. 0 squared is 1. 0 squared is 0. 1 squared is 1, 3 squared is 9. Now if I add these up, I get 20. So that is this part of the formula, the sum of the square deviations. Next step is divide by, let's see, I've got 5 pieces of data, and the formula for sample standard deviation says divide by 1 less than the number of numbers you have. So that's 4, because I have 5 numbers. 20 divided by 4 is 5. This 5 is the variance, and variance is used in some measures. Some of the more advanced statistical techniques talks about the variance. We're not really going to use it much. I might ask you what it is, but it's that easy. And then to get the standard deviation, we're going to take the square root of that, and the square root of 5 is 2 point something. 2.2. I honestly don't know. I'm just going to leave it the square root of 5. So that's that deviation, standard deviation. Why don't you folks now stop this video, try to set up this table for this set 2a, this set of numbers, and see if you do get a larger standard deviation, because we thought they were going to be a bigger standard deviation. We looked at the dot plot, and then you can try it. I'm gonna erase what I've got here and do that calculation also. And you can always come back and look, or if you get stuck, come back and look. So for this data set, what I'm noticing, if I add up the 12, I mean I could go straight down and add it, but I'm just trying to do this in my head so I don't have to think too hard. That adds to 12, that adds to 12. That's 24 plus 6 more is 30. So it looks like this is going to have the exact same mean of 6. So for this data set, they have the same mean, but they have different standard deviations, different spread. So that's why look at graphs, you look at these numerical measures. So 2 minus 6 is negative 4. 6 minus 6 is negative 2. 6 minus 6 is 0. 8 minus 6 is 2. 10 minus 6 is 4. Again, if we add those up, we get 0, right? So then I'm going to square them. So 16, 4, 0, 4, 16. Now I'm going to add those up. So 32 plus 8 is 40. Then I'm going to divide by 1 less than the number of numbers I have, which is 5 minus 1 is 4. That's 10. I'm going to take the square root. And the square root of 10 is certainly larger than the square root of 5. Because this is 2 point something, and this is 3 point something. So, yep, we checked. We got that. So now these next set of numbers are, the numbers are starting to get a little larger, and maybe we should go do this in a spreadsheet. I can do the same process with the spreadsheet. It's just it'll saves us from thinking so hard about the values. Okay, so I will make sure I do that on a different video and make these available together.